Good morning, good afternoon, everyone. My name is Chris Doran. I am a technical sales specialist for Global Test Supply. Thank you for joining our webinar today, brought to you by Global Test Supply University. To start off, just a quick note there, we had a slight change for the plan for today's webinar. Originally, we wanted to cover EV charging and solar, the common pains and points and solutions. However, during the preparation portion, as we prepared for this webinar, it became apparent that there would just be too much information to cover and we wouldn't have enough time to kind of cram it all into an hour session. So we decided that we were going to split the presentation into two webinars. So today, the topic and the title is going to be solar trends and PV systems, troubleshooting PV systems safely as well. And we will have a follow-up webinar likely in the beginning of 2023. We will keep you all informed on the progress and the scheduling of that second webinar. Again, it was just way too much information to cram into 1 hour session, so we decided to split. So apologies to if this causes any inconvenience. There is a lot of information we are going to cover today, a lot of really good information that we are going to cover today. So we do hope that you stay connected. And again, we'll keep you posted on that second webinar, likely in the beginning of 2023. So again, the presentation will last 40 to 45 minutes, a lot of information to cover. We will have an allotted time at the end of the presentation, 10, 15, 20 minutes, however much time allows, for the Q&A portion. If you have any questions throughout the presentation, whether it be on a particular slide, a product that we're covering, anything, please use the question or the chat feature to submit any and all of your questions. And again, we'll get to it during the Q&A period. Global Test Supply and Fluke have been working closely together for many years. We pride ourselves on being a leading distributor of Fluke in the US. This is a result of our dedication to offering you our product expertise, our customer service, as well as our competitive pricing. Getting started today, the webinar is presented by Sean Silvey. Sean has been with Fluke as a products application specialist, for the last 7 or so years. Prior to working at Fluke, Sean was in the HVAC industry for 15 years, working on residential and commercial applications. In addition to his wealth of technical knowledge and experience, Sean has become an integral member of Fluke's Clean Energy Initiative, focusing on tools for the EV charging and solar segments. So Sean, I will turn the presentation over to you.
Hey, thanks, Chris. And yeah, thanks everybody for attending this afternoon or this evening, depending on where you're at, or maybe it's in the morning still for you. So again, as mentioned, yeah, with EV and with solar, two great subjects to talk about. We're just realizing that there was just so much information. Let's focus on the solar one today, and then we will focus on our EV one on the next one, because there's a lot of great, just tons of information on it. So today we're going to be focusing on the solar trends and the troubleshooting of the PV systems. There's going to be a lot of information on this. So before I get started, just thank you, Global Test Supply, for allowing me to do this presentation today. So what are we going to cover in today's session? We've got a lot. So we've got trends that we're going to identify in solar, what's happening now. We're going to look at like the components of the PV system. What critical roles, what are those personas that are out in the solar industry, and who should you be talking to in that aspect? We're talking always safety. So what's working safely like, using the right tools for the right job, and then troubleshooting the panels. We're going to be looking at the PV loads, the inverters, the combiner boxes, and we'll wrap up with some tools and then our summary. But as mentioned, there's a lot of information. So let's go ahead and dive in. Trends in solar. Man, solar is everywhere. If you notice in the United States, it's growing exponentially, it seems like. 46% of generation was added just in solar this last year in 21. With that being said, just on solar installations, there was a 19% growth with a record 23.6 gigawatts of DC capacity on that. Even community solar is picking up, where you're having like micro systems. There was a 7% year-over-year growth just on that. Just in residential installations alone, 4.2 gigawatts of DC energy that's being now generated. Even on the utility scale, I mean, we've got the residential, we've got community and commercial, but even on that utility scale of installations, nearly 17 gigawatts of DC has now been designed and installed for that generation aspect. Little keynote, like what I like to talk about as well, is California has been a huge influence on the solar industry. If you go into California, you'll see solar arrays after solar arrays. But ironically, in 2021, Texas overtook that capacity that California had. So as you can imagine, I mean, this is not going away. Solar is being introduced from everything from that residential to commercial, and even the utility companies are really jumping on to help bring this energy into play. So let's look at components in a solar system. If you look about it here, this is a utility scale style system, very large, acreage upon acreage of solar arrays, solar panels. All of these systems are tying into combiner boxes, which allows, 5, 10, 12 solar arrays, lines tying into one combiner box. And then from that going to maybe a battery backup system or going straight to an inverter, which would then go out to the grid. But huge. The capability of these systems are measuring 1500 volts easily. They're even looking at going higher on the voltage output for these panels. But there's a lot of stuff going on. As you can see in just this image alone and the scale, tremendous amount of solar panels are out there. There's thousands of test results that need to be collected. There's literally reporting on a day-to-day basis about what a utility style segment would look like and what the output in generation is. So there's just a ton of information and a ton of testing on part of a utility style scale like this. Now, when we look at the residential and the commercial, the scale goes lower, but the components are still the same. We still have solar panels. We still have maybe an array of solar panels. All of them are either tying into a combiner box, going back into some battery storage system, and then to an inverter, either being used by that consumer, or maybe it's a dual system where they're selling their solar energy that they've done out onto the grid and they're consuming. And that works both ways, whether it's residential or commercial in that aspect. But you can see that even though the size has changed, there's similar measurements and tests that have to be done. There's PV tools that have to be working in this environment. And again, hundreds of tests have to be collected during part of the installation and commissioning aspect, and then that reporting. I have a friend of mine that he's put residential solar into his system, and he actually has a little tablet on his wall. And it'll tell him day to day what he's generated, what his batteries are, everything on that aspect. So real interesting time right now, as you can see that solar's taking off, and a lot of different communities, whether it's residential, commercial, or even utility, are adopting it. So let's kind of break it down. Let's look at just some of the individual components that are going on with this. So let's start with the solar panels. These are single photovoltaic cells that contain semiconductors in them, and they convert this sunlight into electricity. They can also do it into current as well. So a single panel from a manufacturer has a nameplate on the back of it. And based on the irradiance of the sun, the intensity of the sun coming into it, you can generate so much voltage and current coming out of it. So you put more and more of these panels into series, now we can up that voltage and up that current. So based on the design, we can have 1,000 volts or 1,500 volts coming out of these arrays. But this is kind of the main key component when you think about solar. Everybody looks at, you think solar, you automatically go to the solar panels. Now with that, depending on the type of system, you may have a combiner box. Most of the utility scale and your commercial scale will have a combiner box. They will take 10, 12 solar panels, combine it into one box, as you can see in the picture here, all the multiple wires going into it. And then at that point, they'll have a positive and a negative conductor going to the inverter. This definitely houses your overcurrent protection, like your fuses. But this is a great place for a technician to go out and start troubleshooting as well. They can open up the combiner box and make sure that the amperage is equal on all of the different system, maybe the voltage. It's a good way to go in and check if you have any ground faults happening. You can go here first to identify that and then move out into the system and determine where that's happening. Now, some systems, like I mentioned, have battery storage. You would go from your solar panels, you're generating that DC voltage and current. You're going to go to your combiner box and combine all of that together. And then from that point, you may have battery storage. This is where we're going to feed those battery systems, build up that DC, and then that way we can either utilize that if there was a demand load. Maybe on a utility scale, they need to dump the battery banks during a high demand in the mornings or in the evenings, something of that nature. Or they are using the battery storage systems to help regulate the voltage going into the inverter to have constant output voltage on your AC side. So again, two different methods on the battery storage. But if you do have battery storage, they need to be tested. Most manufacturers recommend replacing the battery when it falls below 80% of its capacity. So we want to make sure and be able to test that type of stuff and get out there and troubleshoot it, make sure that the battery storage systems are going to dump when they need to dump. Now, also kind of really the key when you think about the solar panels as being what you physically see in the system, really the heart of the system is going to be your inverter. That's taking with the solar panels DC electricity, it's converting it to that AC side. The inverter also converts that AC and gives it a 60 hertz signal. So we're going to dump that out onto the grid. Again, an inverter can be very small, and it can be on a residential side, or it can be very large. Some of the 1,500 volt inverters that I've seen are as big as a VW bus, and they're just incredible, on that larger aspect. But again, that's the key component of the inverter. It's taking that DC and turning it into AC so we can use it in our day-to-day lives. Now, on a utility level, typically it's going to go straight to the substation. It's going to go straight up to the grid. Typically, you'll go from your inverter to a step-up transformer. That step-up transformer is then going to get it to whatever voltage we need out onto the grid. So these are kind of the key components that we can see in every solar system, solar installation, whether it's residential, commercial, or in utility level. Now, who works on this type of stuff? So really, if you think about it, there are many players in a solar installation. Whether it's that PV design aspect of it, the electrician who's working with them as well, obviously that solar technician and installer who's going to go out once it's designed for that capacity, they're the ones that's going to be going out and installing all of the racking, all of those solar panels and getting them put into place, running all of the wires, the endless miles of wire and connections that need to be made, all going to just a combiner box. And then from that combiner box, trenching out and digging lines that would go to your inverter. And you're going to have multiple combiner boxes, sometimes just going to one inverter. You're going to have a solar advisors that's going to make sure that everything's working correctly. And finally, once we've got the installation done, we've commissioned it, you're going to have an operations and maintenance team that's going to be able to go out and work on these systems, maintain them, and you're going to have a manager that's going to be in charge of that. So those are some of the critical roles on that. Let's kind of break it down to what they do. That PV designer builds out the system. He designs it. A utility level, or even on that residential side, says, well, how much can we generate for this site and what the output would be? And that's where your designer's going to come in. They're typically electricians as well. They're going to come in and design the aspect. They're going to know the panel manufacturer's specs. They're going to know which inverter to put in, which combiner boxes should be used. They're going to be designing the whole aspect to be generating whatever amount of energy needs to come out of the system. They're going to know the standards. They're going to know the building codes of what that would look like for that system. Your solar tech and that installer is really that next aspect. They're going to take those blueprints. They're going to take that information and they're going to start installing. They're going to be putting in the racking. They're going to be putting the panels on the racking, as I mentioned before, making all those hard connections. Some of these systems are fixed mounted. They're going to be south facing to where they can get the most of the sun. Some of these will be designed on actuators to where they actually spin and turn based on the rotation of the earth and the sun itself. So a lot of that takes into play for your wire management and what it should look like. They're also the ones that are going to be troubleshooting the systems if there's any deficiencies or malfunctions during that installation aspect of it. Now your advisor's got a key role because after everything or during the installation aspect of it, they're going to be looking at the load profiles. They're going to be doing environmental studies and conditions. They're going to make sure that the annual power output should be right based on the solar irradiance. They're really going to help define the capacity of that system and make sure that it's going to give consistent power coming out of it. And then finally, that operations maintenance team. Once that system has been installed, commissioned, a lot of these solar systems are out in the middle of nowhere. They've bought a plot of land. They're able to do the installation out there. That's where these inverters can be actually pretty smart. They're going to be hooked up to some type of CMMS system. If something faults or goes down, it's going to generate a report or give an indication that they need to get the operations and maintenance team to come out and start doing some troubleshooting. So with that, you have all of the components in the solar system. You have the different individuals working in that solar environment. There's a lot going on. There's a ton of wiring connections and terminations that need to be looked at, whether there's corrosion, something's loose, water damage. I mean, again, these are out in an environment where water can affect even the wiring components. Having wire management is huge in this environment. Imagine those actuators spinning and rotating. If you get a pinched wire in there, now you've caused a ground fault. You've shorted out the system. You're not getting the capacity and the load you need part of that. Most of these components are pretty simple. Your combiner boxes, your inverters are pretty smart, but I mean, it's a box sitting out there. But all of those solar panels require attention. Are they dirty? Are there's damage to it? Again, those are all the different inspections that need to take place in this line of operation. Now, all I've talked about is that utility side and some of the ground mounting systems, but even the commercial ones are installed on rooftops. There's again where you're going to have to go out and make sure that anything penetrating the roof, everything's sealed correctly. You're not going to have any damage on that. And then again, if you have those battery systems, well, that's a whole nother level of making sure that everything's clean, your batteries are operating correctly, the charge, anything that needs to be done, or if you even need to do replacement. So let's kind of dig into some of the problems. So first, let's start with our solar panels, because that's a pretty big one. Well, who's going out on it? You know, every one of the personas that we talked about, the designer, the solar advisor, they're the ones that's going to be doing some of this troubleshooting. And what's in their tool bag when they go out and do it? Well, typically at this point, you're going to need a few tools. You're going to need a clamp meter. You're going to need to be able to measure voltage and current. You need to know what the irradiance is so you can validate the output of the solar panel. So you're going to need some type of an irradiance meter. And then a thermal imager is going to be also a crucial tool to be able to troubleshoot hot spots, cracks in the system. Maybe you have a bypass diode on the solar panel that has malfunctioned, leaking current and voltage back into the panel system. You know, the panels are designed to push voltage and current out of them. They don't want to have voltage and current come back into them. So really, voltage and current is the key component to these panels. You know, there's scenarios where they can go down. Either you're going to have one solar panel go down, or you could have an array of panels go down. And this is where that technician is going to need to go out and troubleshoot that. He's going to need a clamp meter. He's going to need a be able to measure voltage, determine what his irradiance is so he can get the correct output of voltage coming into it. You know, this is where you're going to have a lot of visual inspections as well. Some companies actually have a thermal imager connected to a drone, and they'll run out and do studies like biannual and can look through the different systems and run through. It's a time saving and cost saving for sure, but even on some of these other systems, you're going to have a technician walking miles and miles of panels looking to see if there's obvious damage happening. Maybe there was an accidental disconnect. Again, these are environmental conditions. Maybe there was animals or something that got into it that chewed up wires or did something of that nature. But once they find that problem, you know, they're going to have to do the repair, and then they'll have to go back to the combiner box and either replace the fuse if the fuse blew, or bring it back into play. You know, maybe there's a circuit breaker right there. They're going to reset it. But again, all of these wires have connections. All of those connections and the wire management, water can get in and cause rust and cause damage, can short out a system. This is where you have ground fault issues happening as well on the panels. Just key components that a technician would need to come out and troubleshoot and look at. Now with that, again, the solar panels, their main goal is to do DC voltage and current. Know that you have a meter on hand that you're going to be able to go out and double check that. Now there's going to be slides later, but know that you have the right category rated tool as well for your environment. That's a key component. If you're working on 1,000-volt systems, make sure you have a Cat 3 1,000-volt rated meter. If you're working on 1,500-volt systems, again, make sure you have a Cat 3 1,500-volt rated meter that's going to handle that. So let's go ahead and move on now to the load. This is a big one because this is what everything is being generated off of. We're going through our panels, they're generating voltage and current, going through our combiner boxes, going through the system. Who's doing this? Well, every one of our personas have the ability to, at some point, they're going to be checking the load of the system. What's in their tool bag? Really, not much has changed. They still have a clamp meter or a DMM. They still need to measure voltage and current coming out of the system. They still may need a thermal imager to be checking for hot spots, anything happening at that aspect. Even a scope. They may need to have a scope meter in this realm, just doing DC measurements. You know, a scope is going to be able to do that. You know, really, if you think about the load, it's the complete system. It's the load, the electrical load that's going to whatever's being consumed. We want to make sure at that aspect that we have a balance of load. We want to make sure that, again, any fuses, switches, breakers that are have been popped, we can now isolate that and determine what caused that problem. You know, for years I worked as an HVAC technician, and when a fuse blew, you went out and typically what would be the thing? Well, I'm just going to replace the fuse. Something happened, something shorted. But you really got to do some investigation. You got to do some digging on that and determine what caused that fuse to blow. If you replace the fuse, chances are without any inspection or investigation, the fuse will pop again. So that's where we want to really get out and do some analysis and see what's happening with that. And that's where you'd be using a DMM or a clamp meter or even a scope to determine what that looks like. You know, broken wires can affect that. Obviously, if you have a three-phase system, you may need to be doing some insulation testing, validating that you don't have any ground faults or shorts going to ground. That would be a good tool in this aspect, making sure. When I was out in Oregon, they were having fault conditions happening. The load was having an issue. They did all of their investigation, determined that everything was working great from the solar panels all the way to the inverter. But once the inverter, after it left the inverter going to the step-up transformer, it kept tripping out. So once we did some investigation, we took a high voltage insulation tester, ran out there and started doing some testing in that aspect. Come to find out, when they buried the three-phase line going from the inverter to the step-up transformer, they nicked the line. When it got hot enough, got enough current running across it, it shorted out and caused the inverter to trip and didn't get anything to the transformer. So again, it was a load analysis that we did on that. So just making sure that you have the right tools in that aspect to be able to go in and troubleshoot that type of system. Now let's talk about the inverters. You know, as I mentioned, really the inverter is the heart of the system. All of our personas are going to be going out and validating that it's working correctly, that it was designed correctly. At this point, what's in their tool bag? Well, there's going to be a ton of tools on that inverter side. Again, we're taking the information going from DC to AC. We need to know what our voltage and current is coming in. On the DC side, we need to know what's coming out. We also may need a thermal imager. Maybe we have hot or damaged components in that, and it'd be easily detectable with a thermal imager. But also too, we may need some type of power quality unit. With some of the power quality units now, we can do DC load analysis. So we might be able to do an analysis on that DC side of it as well as that AC side and do an efficiency on our inverter and see what's happening. In one aspect, I was working with a company and their inverter kept tripping. They determined that the inverter was working correctly, all the components were working correctly. We put a power quality unit on the AC side of the inverter. Come to find out, they were getting dirty voltage coming from the utility. Something downstream was sending harmonics, sending, I don't think it was a transient, but it basically, the inverter was smart enough that it caused that to trip out. So that's really, the inverters are super smart, but there's a lot of components in it. You've got DC capacitors, AC capacitors, you've got electronic boards, tremendous amount of stuff going on. This is where we would want that plethora of all products. We want to be able to go in and check our voltage on our AC and our DC side. We want to make sure that if it's a three-phase type of system, that the loads are balanced correctly. Maybe there's something in the inverter causing something to be tripping, or you're overloaded on one side of it. This is where you would use some type of power quality unit. You could validate that and monitor it, because it may not be happening on during that time that you were checking it. You would have to go out and do a load study on it to see what was happening with it. But the inverters are smart. They typically will tell an indication of what happened to cause it to trip. And that's where that message would be then sent to your operations and maintenance team They would then generate a work order and have a technician come back out and work with it. I know with some inverter manufacturers, you need to have a dedicated technician from that organization to work on that inverter. So that's another key component on that, to be able to have that technician on hand to go out and work on that inverter. And again, they would be able to use the same tools that I just mentioned to troubleshoot, confirm that that part did fail, replace that part, and then validate that the system is up and working again. But really, if you think about it, that inverter is crucial. It is taking that DC power, moving it over to AC, and then getting it out onto the grid. And we just want to make sure that we have the right tools to be able to look on that. You know, there are times that because we're hooking up straight to the utility, that we need to get the utility involved as well to either come out and trip a transformer, pull the fuse so they can work on the system, something of that nature. So that technician who's working on the inverter is probably either working with the utility or working beside them in a sense of getting that inverter back up and working. And finally with this, let's look at the combiner box. Now the combiner box, as I mentioned in all that information prior, we're taking all of those solar panel arrays, tying them together in series, and then running to the combiner box. Well, who's going to be at the combiner box? Again, every one of our personas, the solar advisor, the solar tech, our operations and maintenance manager, they're going to be the ones going to that combiner box to do some analysis to see what happened in the system. The inverter may trip, but it's because of a ground fault or because something happened that caused a fuse to trip. All of that's going to be in our combiner box. The tools that they're going to use, again, is going to be pretty basic. I need a clamp meter. I can get measure current. Maybe I need a regular DMM, but I can measure my voltage and my current, you know, with a clamp meter. A scope is going to play into this, and also my thermal imager. But really, in the combiner box itself, this is the key component that's tying everything together before it goes to the inverter. I've got fuses here. This is where I can check for ground faults. A technician is able to go out to the combiner box and do a check on all of the legs and make sure that everything is balanced. Now, if you have 10 solar arrays or 10 solar panels in series, and you've got 12 of these at the combiner box, they all should be generating the same amount of voltage and the same amount of current, give or take. This is where that technician can go out into that combiner box and do some very quick analysis to determine if one of those arrays are down, or one of those lines are down, or if we've got a ground fault. You know, you can take a DMM. I learned this from a company in Georgia, but what they'll do is they'll trip the fuse, and then they'll do a voltage measurement on the positive and the negative coming from the arrays. If it's equal voltage, they're in good shape. They can go positive to ground and negative to ground and should see the same amount of voltage as it's slowly going and dissipating. It's a great way to check to see if you have ground faults. Now, having the right jaw design, because these combiner boxes can be very tight. So we want to have a good jaw design to be able to go in and grab as many wires as needed to make a current measurement. So it's a key win on that. So we've really talked a lot about the different components, the personas. Really, this slide, I like to bring it all together because you want to make sure that the category rating of your tool is appropriate for the job. The category rating in a fixed solar system is category 3. It goes through that inverter, you're still at category 3, even though you're at the outside. Once you hit the utility, it becomes a category 4 environment. And as we run through the transmission system and on the utility side, once we get back to the consumer, it then goes back to Cat 3 and Cat 2. Know your category rating of your meters and know the voltage that it can handle. This will be either at the input jacks of your meter, someplace on your meter. You need to identify what your category rating is. Also, too, some of these installations are in high altitudes. So we want to take those considerations into play when we think about category rating as well. Very high altitudes will derate your meter and the capability of that. You just want to make sure that you're using the right stuff. A part of NFPA 70E states that part of your personal protective equipment is your digital multimeter. It's an extension of your protection. So you want to make sure that your test leads are good and that your meter is appropriate for that job. And make sure that you're using the right PPE. So let's kind of break down and see what some of the tools are that I mentioned earlier. You know, clamp meter or a digital multimeter is going to be when. A clamp meter is going to allow you to make your DC current measurements, your AC current measurements. This is going to help you again in every aspect of the solar system, whether that's your solar panels, your combiner boxes, or your inverters, even on doing load studies on it. You're able to do that. Make sure that your meter is appropriate and maybe even needs an IP rating for outdoor environments. That IP rating determines how much particles can get into the meter and if it's waterproof. So we just want to make sure that that's appropriate and know that the meter is going to be able to do like DC power. You got to have DC if we're talking solar. But some of those are the key wins to having the right clamp meter in this environment. Also, too, as we mentioned, we talked about an irradiance meter. Now, every one of these solar panels has a nameplate on them. Based on that nameplate at a certain amount of irradiance, you can then determine how much voltage and current is coming out. We got to know what that irradiance looks like. So having a irradiance meter that gives you that information will help you determine if that panel is outputting correctly. You may not even see anything on the panel itself. There may be no cracks, no shorts, but there's something internally causing that panel not to give out the appropriate voltage and current based on the irradiance. This irradiance meter here will actually do the tilt of it because we want to make sure the tilt is right, and temperature plays a big role in the solar panels themselves. If they get too hot, there's a degradation that happens in the panel itself. So we want to make sure that the temperatures are good, the tilt is great, and the irradiance is working. All of that's crucial to what the solar output of the panel or the voltage and the current would look like. Now, as I mentioned too, a DMM is going to be it's a best friend for you. So having a good DMM out there is going to be a key win. Our 87 Max is IP67 rated. Means it's dustproof, shockproof, waterproof. You could submerge this meter into, a gallon of water for 30 minutes, pull it out, and no water has egressed into that meter to cause an internal short. So just have the right meter, for the job. That's really a key win on that. Now, another component, and I talked about this on when we were doing the job in Oregon, is a good insulation tester. Now, based on the voltage and the output, you may only need to go up to 1,000 volts. In some cases, you need to go higher. There's a good practice when we start talking about insulation testing. And it's basically to double the rating or double the voltage output of what the cable is rated for. And what I mean by that is that typical Romex wire that we use for our homes, it's typically 14 gauge 2-wire with a ground. We put 120 volts on it in our house, in our commercial businesses. That cable is actually rated for 600 volts. If we wanted to do an insulation test on that, we would want to put 1,200 volts against that, or if we needed to, we would do it at 1,000 volts at a longer test. We really want to pressurize that insulation and make sure there's no cracks in it. So having a good insulation tester is going to be a key win for you out in the field. And this is also part of the commissioning aspect. The designer came out and designed this system And you're going to have a tremendous amount of tests and reports that go into this prior to commissioning and putting it into operation. And an insulation test is one of those, coming from our combiner boxes especially, and going to our inverter, making sure when they buried it, there was no damage to the conductors. Also too, having a good scope meter is going to be a key win as well. You're going to be able to do some analysis on your sine waves. You're going to be able to determine if anything is coming in as a pulse, anything of that nature. You're going to be able to determine that with a scope meter. Typical scope meters are going to also be able to do DC as much as AC. So you're going to be able to go in, analyze what's happening with the system, or see what's happening with your inverter. It's a great tool to be able to do some troubleshooting with. Also too, I mentioned the thermal imager, and that is a key win. Thermal imagers are between your clamp meter and your radiance meter. I can't stress enough, a good thermal imager is going to help you in a lot of aspects, whether you're looking for hot spots on the panels themselves or looking for issues in your inverter. You're going to be able to determine what's happening with a good thermal imager. Obviously, the higher the resolution, the better the screen, but even a basic thermal imager is going to allow you to get that job done and do some do some reporting out on if the panels have failed. Now, we did mention the battery system. You need to have a battery analyzer as, again, part of that commissioning aspect. Determine your load analysis on it. You're going to be able to do basically the study of the batteries prior to commissioning, and then being able to go out and do a trending analysis with this as well, and determine if those battery capacity is still at that 90% or if it's dropped down and we need to get them replaced. So this is a great tool because it's going to allow you to do that analysis. Now the next two slides are really critical because we talk about power quality. Now, Fluke has made a DC capable power quality analyzer. It's one of the first. There's not too many out in the field that will do DC. Typical power quality analyzers will be AC only. So having the Norma 6000 is a key win on this. This is going to allow you to do DC analysis of your input voltage and current, as well as being able to do AC analysis as well. Again, we're checking for if there's an unbalance of your current. Maybe we have harmonic issues happening back at the inverter, but really a key win to doing some logging and some troubleshooting. Now the 1777 is an AC only, great unit, touch screen. Again, this is going to help us on that AC side of the inverter. As I mentioned, that company in Georgia where everything was working great with the system, it was actually the utility side that was causing the error. Having this type of unit is going to validate that information to be able to then to go and report that back to the utility to get that resolved so our system can be up and running again. And then finally, I like to throw in the II910. Now, really, if you think about all the tools we've talked about, they really help on the solar aspect of it, whether it's the solar panels, the combiner boxes, all of your lines and your conductors, all going back into the inverter and even back up after the inverter to the step-up transformer. But once we get into some of the utility style in our substations, this is where an II910 can be very effective. This will help determine at a safe level if you have partial discharge, key failures that could be happening on that in that substation. So really, in summary, use the right tool for the right job. Having the right meter is going to help you check for ground faults. Make sure that you're really testing stuff, part of your installation. Again, I didn't throw this slide in, but having a proving unit in your hands is going to do a live dead live test for your meter. That is part of the standard to make sure that you do a live dead live test on your meter before you put it into action. Too many times an arc flash happens or a fault happens because the batteries were low or something of that nature, and the technician went out thinking his meter was working correctly, did a test, and something happened. So we want to avoid that. Hopefully you kind of got some of the some of the talk that we discussed. You can see some common issues that these PV systems have and how to avoid them. Obviously, using a power quality unit will help you if you have harmonic problems in that system. But again, just practice safety. That's really the key win on this. Whether you're out in that field, just in your general workplace, make sure that you're using the right tools, the right correct rated tools to be working out in that field.
First and foremost, thank you very much, Sean, for the presentation. I know everyone that we covered a lot of material, which goes back to our original point as to why we decided to split this webinar up in two, to make sure that we had an allotted time for Q&A, as well as, you know, try to avoid the information overload as best as possible as well. So it is time to try and take advantage of having an expert like Sean with us connected today. So please, we have about 10 minutes or so. Get all your questions in using the question feature or the chat feature, whichever you prefer. We'll take the time that's needed to be able to answer these questions as they come in. A quick note, if you have any product specific questions, you know, we talked a lot about product specific tools that we can use for this particular application, whether it be multimeters, thermal imagers, power quality, and the rest. If you have anything specific as per, you know, trying to figure out what tool is best for you to buy, what multimeter, what category you need for your application, what thermal imager you need, any upgrade, anything like that, I encourage you to go to our website, globaltestsupply.com. You're going to see our list of products, pricing, availability, all the data sheets, manuals if you're having an issue using one. Along with all of that, you'll find our contact info to get in touch with one of our technical representatives to answer and help you with any and all questions that you have. You can give us a call, you can send us an email, you can connect with a tech member using live chat, during our hours of operation. So please go to globaltestsupply.com and take advantage there. So we have a few questions. I also wanted to bring up a question that we had in a previous webinar that kind of spurred a little bit of a conversation because I thought that was excellent. But first and foremost, a question that we get on our end a lot is, you know, we'll put it this way: is there a starter pack that someone would need, someone should use, or definitely go out and you know, think about when getting into, you know, the inspection, the maintenance side of things when it comes to solar?
Yeah, that's a really good question, Chris. I think really 2 to 3 basic components would help anybody who wants to start into the solar industry. Obviously, first and foremost, having a good clamp meter. You need to be able to measure that voltage and current, because really that's how the system's designed, is to be able to output that DC. Some of the residential ones actually have little mini inverters on the back of the solar panel, and those all tie in and go into series. But we need to be able to check that voltage and the current. And also too, having a good irradiance meter, because again, that's going to help you analyze if the panel is outputting correctly. You can add thermal imaging on later. You can always add some of those other components as you get more advanced into the solar workflow and stuff. But really, a good clamp meter and a good irradiance meter is going to be a key win.
Fantastic. Quick reminder, we do have, I think it's in particular when talking about thermal imaging, power quality, this, that, the other, some of the higher end models. At the bottom of that slide, you can see that Global Test Supply offers a rental option for a lot of these higher end meters where, you know, if you're just starting out, not really sure what to use, or, you know, how often you're going to use a thermal imager or anything like that, go to globaltestsupply.com. We have a page dedicated to our rentals, where you can check out all the options that we have, so that, you know, if you want to demo it, you want to make sure that it's useful to you, as well as, you know, rent it whenever you need it. We're there to help you in that regard. So in a previous webinar, we talked about um, the touchy subject, Sean, of of the balance between, all the legislation, we'll say shared utilities, and what the future could bring in terms of battery powered cars and their charging stations and this, that, the other. I'd just like to bring that back up now, because it really did spur a great conversation, and I think it's useful to know, you mentioned about what they're doing in Australia, for instance.
Yeah, obviously solar is being adopted globally. It's everywhere, it's being installed. We're really getting to see a balance, and hopefully people understand it's a balance of energy generation between our traditional coal and natural gas and even nuclear, that it's not one or the other. It's definitely going to be a balance of this, more and more people are going to be out in the world, and there's more consumption. So we need to have more generation. We didn't even talk about really like microgrid communities that, a community here could be just doing their own little solar, and they're sharing that energy that they produce between them. Great conversation came up earlier about electric vehicles, and I know again we'll talk heavy about electric vehicles, but electric vehicles have a tremendous amount of batteries. And there's now legislation looking at, if I had an electric vehicle, could I pull from the batteries from that and supplement back to the grid? So if I'm, because we all know that, I mean, there's billions of dollars now being introduced just into the American market for infrastructure for electric vehicles. Being able to take an electric vehicle from LA and drive to New York City, what does that look like? My wife and I go round and round on this, because she's a combustion gas person and probably will always be a combustion gas person. And we've had debates about this, about what does that infrastructure even look like, to be able to handle that, to go from one area with an electric vehicle far away, for hundreds and hundreds of miles, and what that would look like. But if you think about it, there's a ton of legislation and stuff that needs to be really enacted. There's great courses that you can take if you're really interested in this. Do some research. There's legislation right now talking about, that we would have the ability to take the DC voltage and current from your car, that energy there, and put it back onto the grid. And they might not even tell you that they're doing that. So there's a lot of conversation that's going into that. You had mentioned the Australian, and it's really an interesting topic, because in Australia, as big as that country is, there's a lot of residential solar that's out there. And a lot of them actually have battery backup systems. The utility has the control of the battery backup systems. I'm sure legislation went into play on that, but if there is a grid demand, something's happening on the system itself, the utility has the authority to open up the battery systems that you have in your house and dump that energy back onto the grid to supplement it. Even though you manufactured it, it was your battery banks, and if you think about it, your energy. So there's just, this is a big conversation, and I think we're not going to know more, as the time plays out, as solar becomes even more and more advanced. If you think about solar 20 years ago, we could probably get 20 volts or even 40 volts out of a solar panel by itself. Well, the solar panel manufacturers are up in their game. You're getting 72 volts on a basic panel now. They're getting even higher. The demand is more and more. I mentioned that 1500 volt was for utility. Well, back in the day, 600 volt was the max you would see ever for residential, and 1000 for commercial. That's now stepped up. Now we're seeing 1,000 in the residential, 1,500 in commercial, and they're looking at 2 to 3,000 volt systems just for the utility level. It's getting bigger and bigger. It's just getting incredible. But yeah, if you're really interested, and I know our time's kind of dwindling on us, but do some research, go to the different events, really reach out to the different organizations, because I mean, you'll be able to do a lot of investigating where the legislation's sitting right now, what's happening with solar and electric vehicle. Just be more aware. I always say, be smart about it. Yeah, do your research.
Absolutely. So ladies, gents, we do have time for maybe one more question in. So if you can squeeze that in for the hour does dwindle away on us, please do so. A quick reminder, use the chat feature, use the question feature if you have that. If you have any questions that come up after the presentation, the light bulb moment, as soon as we click goodbye, don't hesitate, don't worry. Again, globaltestsupply.com, you'll find our contact info. You can get in touch with one of our technical representatives who will be able to answer your questions. If we're not able to answer your questions, we do have access to Sean and all his expertise, as well as the entire Fluke team as well. So we can definitely get basically any question that you possibly have answered in as detailed as possible. So please connect to us there. Doesn't look like we've had anything come in just yet. So again, you know, if you're looking for, if you've got your startup kit already, you know, you've got your clamp meter, you've got your multimeter, you've got your thermal imager, anything of the sort, maybe you need an upgrade, maybe you want to look into something that's a little bit better in terms of your application, please contact us. One of our team members will be able to help you and will be glad to do so. Just a quick note, everyone who registered, everyone who participated today will get a link sent to them with a YouTube link for this presentation, as well as will be uploaded on our websites in the coming days and weeks. So please don't worry about if you want to revisit this presentation again at a later date. Again, also, whether it be December this year or January of next year, we will have the EV topic scheduled and up on our website, as well as an email will be sent to all of you to let you know when that specific date is. So because we had no questions coming in, we are about a minute left. I will thank you all for participating in today's webinar. And Sean, thank you very much again for the presentation. We hope that everyone found it informative and helpful. Again, we're here to help you. globaltestsupply.com, our product list, everything under the sun that you can possibly think of is there. So please don't hesitate to go on our website, contact us, and we'll be happy to help. At the end of this webinar, there is a short survey that we ask you to complete. Your feedback is going to help us improving these webinars, as well as more importantly, bringing you topics that are of interest to you. When it comes to solar, the conversation continues and it will continue to evolve. So we'll continue to bring these types of topics as well. We do have one more webinar scheduled for the calendar year of 2022. It's at the end of November. You can find out the schedule, the date, the time, etc. at globaltestsupply.com on the training page. So please be sure to check us out there. In the new year, we'll have the dates of all of our upcoming webinars as well, including the EV one that we will be scheduled. And lastly, don't forget that as a thank you for attending the webinar today, your name will be entered into a draw to win $100 on your next online purchase. We will announce the winners on our social media channel, so please be sure to check us out there. Once again, a very big thank you for participating today. A very big thank you to Sean, and hope you all have a great day.
Thanks, everyone. Be safe out there.